Stone is thrown vertically upward with the speed of 24 meters per second. How fast is it moving when it's at the height of 13 meters? Second piece of the problem, how much time is required to reach these heights? We'll start from the first part of the problem. So we have here two numerical data. We have 24 meters per second, and this is our initial velocity, magnitude, and we have heights 13 meters. Because we're dealing with the vertical motion, we have gravity acceleration 9.8 meters per second square. Then we have to start from the picture. We have initial point from which we throw stone upward, so it moves, and somewhere here he passes through the distance from the origin equal 13 meters. So this is our final point. Now we have gravity acceleration directed downward equal 9.8 meter per second square, and we have initial velocity represented by arrow at the initial point equal 24 meter per second. Now this is our picture, and we have to assign axis. Axis has to be along the path of the motion. Up or down doesn't matter. I put in our case axis upward, so our velocity initial will be positive. Acceleration, because it's directed opposite to the x-axis, will be negative, so you have to assign sign minus to the acceleration. Now we have to put origin somewhere, and I will pick up origin at initial point, so initial coordinate will be equal 0. Final coordinate will be equal 13 meters to ensure that the distance between initial and final point is equal 13 meters. Now we need to find final velocity v final at the point f final point. Look what we have. We have x initial, we have x final, we have v initial, we have acceleration. We are looking for the v final. The easiest way to calculate v final is to use third formula from your formula sheet. X final equal x initial plus v final square minus v initial square divided by 2a. If you will plug in numbers in these formulas, you will have 13 meters equal 0 meters plus unknown final velocity magnitude minus 24 meters per second squared divided by 2 times negative 9.8 meter per second square. Only one unknown in this equation we have. This is v final. Solving this equation for the v final, you have to take square root, and whenever you will take square root, you will have two solutions, plus or minus 17.9 meter per second. What is our value? What do we need to find? How fast it's moving. So we need to find speed. So the speed is just the value without the sign. So the final solution is 17.9 meter per second. Why do we have two solutions? Because one velocity will have directed upward. We move through the final point on the way up, then we return back and moving through the same point on the way down. So another value will have negative value, will be opposite to the x-axis. Now second part of the problem. In this case, because you deal with the final point the same as in the initial point, you have to use our previous picture. The only what you need to find is delta t. And how do we have to find delta t? There are two ways to do that. So look, first of all, you can use either of the equations, of course, but the easiest way to use equation v final equal v initial plus a delta t. Just keep in mind that we have two values of the v final. One is positive, one is negative. So we have actually two equations. One is 17.9 meter per second equal 24 meter per second minus 9.8 meter per second square times delta t, and from this delta t will be equal 17.9 meter per second minus 24 meter per second divided by negative 9.8 meter per second square. If you will solve this equation, you will have 0.62 seconds. Second equation will have, it will pick up negative value for the velocity, 17.9 negative meter per second, equal 24 meter per second, minus 9.8 meter per second square times delta t. And from here, you will find that your delta t will be equal minus 17.9 meter per second minus 24 meter per second divided by negative 9.8 meter per second square. If you will solve this formula, you will have 4.28 seconds. So we have two different values for the time interval. Why do we have two? Because our stone passes the final point twice, one on the way up, so time to fly up is 0.62 seconds, another on the way down, so time interval till the stone will go through the final point moving backward equal 4.28 seconds. We solved the problem.